So the atomic number is symbolized by Z, and it refers to the number of protons in a nucleus. And you can find the atomic number on the periodic table, so we're going to talk about hydrogen in this video. So for hydrogen, hydrogen's atomic number is 1, so it's right here. So there's 1 proton in the nucleus of a hydrogen atom. In a neutral atom, the number of protons is equal to the number of electrons, because in a neutral atom there's no overall charge, and the positive charges of the protons completely balance with the negative charges of the electrons. So let's go ahead and draw an atom of hydrogen. So we know the atomic number of hydrogen is 1, so there's 1 proton in the nucleus. So there's my 1 proton in the nucleus. And we're talking about a neutral hydrogen atom, so there's 1 electron. I'm going to draw that 1 electron somewhere outside the nucleus, and I'm going to use the oversimplified Bohr model, right? So this isn't actually what an atom looks like, but it's a very simple view that helps you get started. So this is one version of hydrogen. So this is one isotope of hydrogen. So this is called protium. So let me go ahead and write that here. So this is protium. And let's talk about isotopes. An isotope, isotopes are atoms of a single element. So we're talking about hydrogen here that have that differ in the number of neutrons in their nuclei. And so let's talk about the next isotope of hydrogen. So this is called deuterium. So let me go ahead and write deuterium here. Deuterium is hydrogen, so it must have 1 proton in the nucleus, and it must have 1 electron outside the nucleus. But if you look at the definition for isotopes, right, atoms of a single element that differ in the number of neutrons. Protium has 0 neutrons in the nucleus. Deuterium has 1. So let me go ahead and draw in deuterium's 1 neutron. I'll use blue here, so neutrons are going to be blue. So deuterium has 1 neutron, and since neutrons have mass, right, deuterium has more mass than protium. So isotopes have different masses because they differ in terms of number of neutrons. Notice, though, that they have the same atomic number. They have the same number of protons in the nucleus, right? It's 1 proton in the nucleus. And that's important because if you change the number of protons, you're changing the element. And that's not what we're doing here. We're talking about atoms of a single element. Deuterium is still hydrogen. It's an isotope. And finally, our last isotope, which is tritium. So tritium has 1 proton in the nucleus, right? 1 electron outside the nucleus. So we draw that in here. And it must differ in terms of number of neutrons. So tritium has 2 neutrons. I'm going to go ahead and draw the 2 neutrons here in the nucleus. And so those are the isotopes of hydrogen. So how do we distinguish between the different isotopes? Right, well, we're going to write little symbols to represent these isotopes. And so the symbol that we'll draw here for protium is going to have the element symbol, which is, of course, hydrogen. And then down here, we're going to write the atomic number. So the subscript is the atomic number, which is 1, because there's 1 proton in the nucleus. And then for the superscript, we're going to write in the mass number. So let me move down here so we can look at the definition for the mass number. The mass number is the combined number of protons and neutrons in a nucleus. So it's protons and neutrons, and it's symbolized by A. So A is the mass number, which is equal to the number of protons. That's the atomic number, which we symbolize by Z. Right, plus the number of neutrons. So A is equal to Z plus N. And for protium, let's look at protium here, right? So in the nucleus, there's only 1 proton and 0 neutrons. So 1 plus 0 gives us a mass number of 1. And I'll use red here for mass number so we can distinguish. Right, so mass number is red, and let me use a different color here for the atomic number. Let me use magenta here. So the subscript, right, is the atomic number, and that's Z, and the superscript is the mass number, and that's A. All right, so this symbol represents the protium isotope. So let's draw one for deuterium. Right, so it's hydrogen, so we put an H here. there's still one proton in the nucleus, right? One proton in the nucleus, so we put an atomic number of 1. The mass number is a superscript. It's the combined number of protons and neutrons. So we look in the nucleus here, there's one proton and one neutron. So 1 plus 1 is equal to 2. So we put a 2 here for the superscript. And finally for tritium, it's still hydrogen, so we put hydrogen here. All right, there's one proton in the nucleus, atomic number of 1, so we put a 1 here. And then the combined number of protons and neutrons, that would be 3, right? So 1 proton plus 2 neutrons gives us 3. So there's the symbol for tritium. So here are the isotopes of hydrogen, and using these symbols allows us to differentiate between them. All right, let's take what we've learned and do a few more practice problems here. All right, so let's look at a symbol for carbon. So here we have carbon with subscript 6, superscript 12. All right, and if we want to know how many protons, electrons, and neutrons there are, so let's first think about protons. Well, we know that the subscript is the atomic number, and the atomic number is equal to the number of protons. So there are 6 protons in this atom of carbon. And if it's a neutral atom of carbon, the number of electrons must be equal to the number of protons. So if there are 6 protons, there must also be 6 electrons. And finally, how do we figure out the number of neutrons? Well, let's go ahead and write down the formula we discussed. The mass number is equal to the atomic number plus the number of neutrons. Right? So the mass number was right here, right? That's 12, so we can put in a 12. The atomic number was 6, right here, so we put in a 6. Right, plus the number of neutrons, So the number of neutrons is just equal to 12 minus 6, which is, of course, 6. So there are 6 neutrons. So just subtract the atomic number from the mass number, and you'll get the number of neutrons in your atom. All right, let's do another one. So this is carbon, and this time we have a superscript of 13. Right, so the atomic number doesn't change when you're talking about an isotope. Right? If you change the atomic number, you change the element. So there's still 6 protons in the nucleus of this atom. And in a neutral atom, there must be the equal number of electrons, so 6 electrons. And then finally, how many neutrons are there? Well, just like we did before, we subtract the atomic number from the mass number. Right, so we just have to do 13 minus 6 to figure out the number of neutrons. So 13 minus 6 is, of course, 7. So there are 7 neutrons in this atom. All right, another way to represent isotopes, let's say we wanted to represent this isotope in a different way. Sometimes you'll see it where you write the name of the element, so this is carbon, and then you put a hyphen here, and then you put the mass number. So carbon hyphen 13 refers to this isotope of carbon, and this is called hyphen notation. So let me go ahead and write this hyphen notation. All right, let's do one more example here. Let's do one that looks a little bit scarier. So let's do uranium, right? So U is uranium. The atomic number of uranium is 92. The mass number for this isotope is 235. So how many protons, electrons, and neutrons in this atom of uranium? All right, so once again, for protons, we look at the atomic number. That's 92, so there must be 92 protons. In a neutral atom, the number of electrons is equal to the number of protons, so there are 92 electrons. And then finally, to figure out the number of neutrons, right, we subtract this number from the mass number. So we just need to do 235 minus 92, and that gives us 143. All right, so there are 143 neutrons.